basis and dimension. Basis and dimension. So take your definition. Definition. Let V be a vector space. Let V be a vector space over F. What is F, ma? Field. F is a field. Today's day is so let me be a vector space over here. F is nothing but our field. Okay. And beta be a finite subset. Beta be a finite subset of B. Beta be a finite subset of B. Then beta is called a basis for B. Beta is called a basis for B if, first subdivision, beta is linearly independent. First one, beta is linearly independent. Second one, L of beta equal to B. So if these two conditions are satisfied, then the given set is said to be a basis. Okay. What is the meaning of L of beta equal to B? What it represents? Linear span. Beta will be a linear span of the vector space B. So here you have to prove both the things. You have to prove that it is independent as well as you have to prove that it is a linear span. Already we discussed the problems how to check both. Okay, you have to combine both and you have to do the checking for this problem whether it is going to be a basis or not. Okay, so take the problem. Let P of x be the set of all polynomials. Let P of x be the set of all polynomials of degree n over the real numbers. That is, the coefficients will be real numbers. Let capital X is defined as the set 1, x, x square, etc., x power n. Prove that S forms a basis. Prove that S forms a basis of P of x. Yes, forms a basis of P of x. So how you define this P of the vector space here now? P of x. So what is P of x? Set of all polynomials whose coefficients will be a real numbers. You are given that set to be yes defined like this. Now we have to check whether it is a basis or not. For basis, what are the conditions? There is no given. What are the conditions? It should be linearly independent and it should be a linear span. If both these conditions are satisfied, then we can say that it is a basis. So first we are going to check whether it is independent or not. How will you do the checking? You all know my problem? What is the statement you will write? What is the equation? What to represent the independent or dependent? I can take only alpha. What is the remaining? General representation. Alpha naught u1 plus alpha naught u0 plus alpha 1 u1 plus etc. should be equal to 0. It is independent if all. Okay, it is dependent if at least one alpha is not zero. It is independent if all alpha is zero. You can do the checking using the determinant concept also. That depends upon the problem what you are going to discuss. Okay, well anyway we can do the checking, but remember the conditions thoroughly. So the first part what you are going to do is that you are going to check whether this S is independent or not. Okay, so start the solution. Let, alright, it is given, so right, given S is equal to, right, this is 1 x square etc. x power n. First part, to prove S is linearly independent. To prove S is linearly independent. So right, let the independent condition equation A0 E1 plus A2 E2 A1 E1 plus A2 E2 plus etc. AN EN should be equal to 0. Here E1 E2 etc. represents the elements in the given set. There we made use of alpha 1, alpha 2 or equal to. Okay, you can make use of the same notations also, nothing wrong. The E0 E1 E2 etc. are the elements in the given set. Okay, instead of alpha we are using it as A0 A1. Otherwise if you want to use alpha also you can use it, nothing wrong. Okay, replace here all the elements, that is A0 into 1 plus A1 into x plus A2 into x square plus etc. AN into x power n equal to 0. E1 into represents the elements in the given set. Now tell me, when this can happen? What is the possibility of this equation to be equal to 0? X is 0. X is our variable. This is possible only if which A? Any one A or all A? All A. Because this is A0 is the coefficient of the constant. A1 is the coefficient of x. A2 will be the coefficient of x squared, etc. So this can be 0 only if all the coefficients are 0. Is that normal? You can rewrite the right hand side to be of a 0 polynomial. How do you write 0 polynomial? Constant is 0. What is the coefficient of x? 0x. X square will be 0x square, 0x cube, etc. 0x power n. This will be our right hand side in terms of a polynomial. So if we include the coefficient of both sides, what will happen? What will happen, boys? This one. Boys, give me the explanation. What will happen to the coefficients when we equate? Which will be 0? A1, etc. All the coefficients will become 0. Only then this equation will become 0. So right, this implies AI equal to 0 for all I. AI equal to 0 for all I. So now we have shown that all the coefficients are 0. So whether it is independent or dependent? Independent. So first condition is true. So right, therefore S is linearly independent. Therefore S is linearly independent. S is linearly independent. S is linearly independent. Now what is the second part you have to prove? Linear span. What is the standard condition to prove that, Parma? Yes, L of beta is contained in or equal to B. We have to prove that B is contained in or equal to L of beta. Okay, so start that. So continue. Second one. To prove L of S is equal to B. To prove L of S is equal to B. Instead of beta we are having S. So right, we know that L x's contained in or equal to what is v here ma? For our problem what is v? Polynomial. So v is nothing but p of x. Now what you are supposed to prove in a proof? V is contained in or equal to L of x. This is what we are trying to prove. That is, we have to prove that P of x is contained in or equal to L of x. You all remember how we proved it? What is the procedure to prove this one? No? We will assume an element in the polynomial. Left hand side we will assume an element. And we will try to show that it can be written as a linear combination of our set S. You all remember it? To prove this one, what is the procedure? We assume an element in our vector space and we show that it can be written as a linear combination of the element in the given set. Okay, that prove pannadala we can show that this is contained in or equal to this one. Okay, the same similar way we are going to prove. Okay, so right next line. Let small p of x belongs to capital P of x. Belongs to capital P of x. So we have to assume an element in our vector space. So right, let P of x equal to a naught plus a1 x plus a2 x square plus etc. an x power n. This is the element in our polynomial P of x. So to prove that it is in L of x, what you are supposed to do? You will show that this can be written as a linear combination of our s. What are the elements in s ma? 1, x square, etc. Can you rewrite this too in terms of that one ma? அது வர மாதிரி இந்த polynomial மாத்த முடியுமா? ஞாபகத்தை ப்ரூவ் பண்ணனும். ஒரு எலிமெண்ட் எடுத்துட்டு அத எலிமெண்ட்டை நம்ம ரீரைட் பண்ணனும். It can be written as a linear combination of the elements in the given set. இங்கேயும் அததான் ப்ரூவ் பண்ணனும். Okay? You take this as the element. Now you have to show that this can be written in the form of elements which is there in our set. Can you rewrite or not? Obviously. What are the elements in S? 1. So how can you rewrite a naught? A naught into 1 plus what is the next element? A1 into x plus a2 into x square plus etc. an into x square. Whether these are the elements in our set S or not? Yes. So it is possible for us to rewrite an element in P of x as a linear combination of elements in the given set S. So what is the proof you can give? What you can say? P of x is contained in or equal to L of x. Okay, this is a very simple problem. Okay, so that here write this P of x, a naught within bracket 1 plus a1 within bracket x, just to show that they are the elements in S. So right, therefore P of x is contained in or equal to L of x. P of x is contained in or equal to L of x. Hence, L of s is equal to L of s is equal to B. So whether both the conditions are satisfied? Yes. So what is the final conclusion you can give? S is a basis. So right, hence capital S forms a basis of P of x. Capital S forms a basis of P of x. Any doubt in this problem? This is one type of checking for the basis. Still many concepts we are going to discuss based on different definitions and theorems. Okay? Any doubt? vary. It may be a matrix, it may be a polynomial, or it may be a R square, or it may be a R cube. Like that one it is going to be there. Okay. So take the next one. Next definition. Next definition. Definition. A vector space. A vector space is said to be. A vector space is said to be finite dimensional. Is said to be finite dimensional if it contains a basis, if it contains a basis with finite number of elements. Finite number of elements. So when a vector space is finite, if the number of elements in the basis is finite. So if the basis is going to contain a finite number of elements, then the vector space is said to be of finite dimensional. Otherwise it will be of infinitely dimensional. Okay. Next one. Next definition. Let V be a finite dimensional vector space over a field F. The number of elements in any basis of V is called the dimension of V and is denoted by DIM for dimension of V, and is denoted by DIM of V. Okay. What is the dimension of V? What is the dimension of V? The number of elements in the basis of V is called the dimension of V. Okay. Next one. Dimension theorem. I will give the statement alone. Dimension theorem. Dimension theorem. Take down. If W1 and W2, W1 and W2 are two subspaces. W1 and W2 are two subspaces of a dimensional vector space V of F, vector space over the field F of V of F, comma, then dimension of W1 plus W2 is equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. This is called as our dimension theorem. Okay, more chances of getting this question in question paper. Okay, if you get this one as a 16 mark means in this entire unit you can easily score the 16 mark. So don't skip this here. Okay, so next one. Again, what you are going to do is that you are going to discuss some more concepts to identify vectors as basis. Okay, first, how was our definition? A It is based on linearly independent and linear span. Apart from that one, we can identify the basis based on the number of elements what we are defining now. Okay, so based on that one also we can identify the basis and the corresponding dimension. So that is the next one you are going to take now. Then we will be discussing the problems based on those conditions, not by definition. Okay, take a note. 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 Let V be a vector space. Let V be a vector space with dimension of V equal to n. With dimension of V equal to n. So what is the assumption we have said here? Dimension of V equal to n. Then a basis will contain how many elements? N elements. The number of elements in any basis is the dimension of V. So if the dimension of V is n, then the basis will contain how many elements? N elements. So right. Then any basis of V, contain n elements. Any basis of V contain n elements. Second one. Let beta be a set. Let beta be a set with cardinality. What is cardinality? Number of elements. Cardinality, the number of elements, it will be normally noted by like this symbol. Cardinality of beta. Cardinality of beta. And then first subdivision. For the second point, first subdivision. If cardinality of beta is less than n, or cardinality of beta is greater than n, then beta does not form a basis of V. Then beta does not form a basis of V. Beta does not form a basis of V. Because what is the dimension of V? It is the number of elements in the basis. Both should be same. So if the number of elements in the basis is either less than n or greater than n, then it is not a basis at all. Next point. Next one. If beta is linearly independent set, if beta is linearly independent set in B with cardinality of beta equal to n, then cardinality of beta equal to n, then beta forms a basis of V. 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 So now we are going to discuss. We have discussed that how to check whether beta is a basis or not based on the cardinality. Okay. So you should know what will be the number of elements in your original vector space, whatever is defined. That will be our first one you have to identify. Then you have to check with your beta what is defined. So if beta is less than n or greater than n, it is not a basis. If it is equal to n, directly you should not conclude it is a basis. What is the other condition you have to check? Linearly independent. If it is less than n or greater than n, directly you can say that it is not a basis. But if it is equal to n, what should be the other condition? It should be linearly independent. Only if it is linearly independent, then you can say that it is going to form a basis of V. Here we are not going to make use of the linear span. Just using the number of elements, we are going to discuss whether it is a basis or not. Okay, can you understand now? Yes? You are good with the conditions? Say, according to the problems, you have to change the way of getting the solution. So, according to the definition, what are the conditions you have to take? It is linear, independent, and it is a linear span. Okay, both are very complicated one. So now, since you know what is the meaning of the dimension, you are going to solve the problem based on the dimension concept. So what is the condition for that? First, you should thoroughly know how to identify the dimension of the given vector space. Okay, well, so if you know that one, it will be equal to here. Then you have to compare with the given set of the bases. Okay, if the number of elements is less than or greater than, what is the conclusion? If the number of elements in the bases is less than or greater than the number of elements in vector space, then it is not a basis. If it is equal, you have to check whether it is linearly independent. Only if it is linearly independent, it is going to be a basis. Okay, equal means you have to check for the independence alone. No need to check for linear span. Okay, then you can say that it is a basis. So now we are going to discuss the problem based on this cardinality condition. Okay, so here is the problem. Determine whether the set 1 1 1, comma 1 0 1 1 1 1 1 0 1 forms the basis of R cube. Okay. Yes. So tell me, how do you check whether it is a basis or not? Forms the basis of R cube. For basis, what is the check condition? We will assume that this is equal to beta. Any condition to basis now? Cardinality of beta should be equal to dimension of B, and it should be independent. If both the conditions are satisfied, then we can say that it is a basis. Tell me, what is cardinality of beta? This is a set beta. How many elements are there? 2. Cardinality and the number of elements intensity. That cardinality. So what is the cardinality of beta? 2. Because in beta there is only 2 elements. Now you should know for the vector space. What is the vector space defined? R cube. You should know what is dimension of R cube. What is the dimension of? 3. R is the set of all real numbers. Okay. R square is 2. R power n is n. So dimension of R cube is equal to 3. So whether it forms a basis or not? Forms a basis or not? No. Why? Cardinality of beta is less than the dimension of R cube. So it is not a basis. Just a simple 2 marks. So right. Cardinality of beta is less than dimension of R cube. Less than dimension of R cube. Hence, beta does not form a basis of R cube. Beta does not form a basis of R cube. Written. If it is equal means what is the next condition you have to check? Linearly independent problem. Okay. Take the next problem. Verify whether the vectors 1 2 0 2 3 0 8 30 0. Whether the vectors 1 2 0 2 3 0 8, 13, 0 is a basis of R cube. Is a basis of R cube. Yes, a basis of R cube. Okay, tell me, what is the first step you will write? Assume the given set to be beta. Okay, so write let beta equal to the given set. Define the given set of elements as beta. So next one, we will identify the dimension of beta as well as dimension of beta. So tell me, what is dimension of beta? 3. How many elements in beta? 3 elements. What is the vector space given here? R cube. What is the dimension of R cube? 3. So dimension of R cube is equal to 3. Whether both are equal? Yes. Can you conclude it is a basis? What is the next one you have to take? Linearly independent. So right. To prove beta is linearly independent. To prove beta is linearly independent. So what is the equation for linearly independent? Alpha 1 u1 plus alpha 2 u2 etc. should be equal to 0. Okay, one way we can check the alpha value and prove it. What is the other way of giving proof? Using determinant. You are no longer using determinant. When there is a set of simultaneous equations, it will go for the determinant constant. If determinant A is 0, determinant dependent or independent? Both the answers now. Dependent. Determinant of A is 0 means dependent. Non-zero means independent. So now we are going to solve this using our determinant rules. Okay, so right. Let alpha 1 2 0 plus alpha 2 2 3 0 plus alpha 3 2 3 0 is equal to 0 0 0. 8 13 0. Since it is a vector, we write the right hand side also as a vector form. Can I identify what we have made? Matrix A. And A equal to 1 2 0 2 3 0 8 13 0. This will be our matrix. Very simplified. Which is 0. Determinant. This is your matrix A. Now check for a determinant of A. Whether 0 or non-zero? 0. Others? 0. So determinant of A is 0. So beta is independent or dependent? Dependent. So right, determinant of A equal to 0. Therefore, beta is linearly dependent. Beta is linearly dependent. So what is the final conclusion you can take? Basis or not a basis? Not a basis. So right, hence beta is not a basis of R cube. Hence beta is not a basis of R cube. Beta is not a basis of R cube. Can you understand how to discuss now? Yes? Now take our next problem. Next one. Determine whether the set 1 plus 2x plus x square, comma 3 plus x square, comma x plus x square forms a basis. Yes. Forms a basis for Dimension of P2 of R equal to 3. Dimension of P2 of R equal to 3. So here what is the type of elements given, ma? Polynomial. It is given as a set of polynomials. Previously it was a vector. Now we are going to discuss a problem based on a polynomial. The same procedure. Tell me what is the dimension of V? 3. Dimension of V is given to be 3. What is dimension of beta? 3. Whether both are equal or not? Yes. Equal means what is the next one you have to check? Independent or dependent. So right? Cardinality of beta equal to 3, which is equal to dimension of P2 of R, which is equal to dimension of P2 of R. Now tell me how will you check the independent one? Same equation, alpha 1, U1 or V1 or whatever relation you want, you can follow. So right, let alpha 1 U1, how many elements are there in the set? Alpha 1 U1 plus alpha 2 U2 plus alpha 3 U3 is equal to 0. Okay, replace your U1 U2 U3. Alpha 1 into 1 plus 2x plus x squared plus alpha 2 into 3 plus x squared plus alpha 3 into x plus x squared, that is equal to 0. Actually, right hand side is a 0 polynomial. It is an understood one, so we are writing that 0 is equal to. How do you rewrite this one? It is a polynomial. Rewrite polynomial. When it is vector and that everything combine the corresponding coefficients. All the constants together, all the x term together, and all the x square term together. What are the constants here? Alpha 1 plus 3 alpha 2. This is the constant. Plus, what are the coefficients of x? 2 alpha 1 plus alpha 2 into x plus then the coefficients of x squared. What are the x squared terms? Alpha 1 plus alpha 2 plus alpha 3 into x squared equal to 0. Because only if you make it as the corresponding coefficients, you can compare it to the right hand side. Okay, now tell me, what are the equations you will get? What are the equations? Alpha 1 plus 3 alpha 2 equal to 0. What is the second equation? 2 alpha 1 plus alpha 3 equal to 0. Last equation, alpha 1 plus alpha 2 plus alpha 3 equal to 0. Equate the coefficient on both the sides. They call it independent concept. So now you have to identify alpha nature, whether it is going to be 0 or non-zero. How you want to discuss? There are many methods. Shall you go for determinant method or find alpha? You have to know whether it is dependent or independent. That's all. So what you can do? Yes, determinant. Okay, well, in the alpha நம்ம கண்டுபிடிக்க தேவையா இருந்தா you can go by any other method and find the alpha. But இங்க என்ன போதும்? Dependent and independent செக் பண்ணா மட்டும் போதும். So you go for your matrix. So write your matrix A. What is your matrix A? 1 3 0. Second one 2 0 1. 2 0 1. Third one 1 1 1. Find what is the determinant of A. Find determinant of A. Minus 4. Others? Minus 4. 0 or non-zero? Non-zero. This is not equal to 0. So not equal to 0 means what is the condition? Linearly independent. And what is the nature of alpha? beta is linearly independent, and alpha 1 equal to alpha 2 equal to alpha 3 equal to 0. Because it is independent means all the alpha should be 0. So tell me a final conclusion. Basis or not a basis? Basis. So right, hence beta is a basis of P2 of R. Beta is a basis of P2 of R. That is a vector space given here. Any doubt, ma'am? So there is nothing a new concept. Already discussed one only. Using that same conditions, we are checking whether it is basis or not a basis. Okay, any doubt? Shall we proceed to the next one? Okay. Take the next problem. Prove that the vectors u1 equal to 1 1 1 1 4 elements, u2 equal to 0 1 1 1, u3 equal to 0 0 1 1, u4 equal to 0 0 0 1, form a basis of F4, F power 4. Form a basis of F power 4. Find the unique representation. Find the unique representation of the arbitrary vector alpha 1, alpha 2, alpha 3, alpha 4 in F power 4, alpha 1, alpha 2, alpha 3, alpha 4 in F power 4 as a linear combination of u1, u2, u3, u4 Can you understand the question, ma'am? Similar one, but there is an extra part. Okay, as usual, first what you have to check that is going to be a basis or not. What is the extra part you have to do? You have to represent this vector as a linear combination of all these four. Actually, we start பண்ணும்போது அப்படியே நம்ம ஸ்டார்ட் பண்ணுவோம். alpha 1 u1 plus alpha 2 u2 தான் ஸ்டார்ட் பண்ணுவோம். இந்த எக்ஸ்ட்ரா ஸ்டெப்ல என்ன பண்ணனும்னா after checking whether is a basis or not, you must try to find your alpha values and rewrite it. That is called as our representation. Okay, what you must try to do? You must try to find the alpha values. Okay, that is the extra step we are going to do. So start the solution. What is coordinate of theta? 4. How many elements are given? 4 elements. So coordinate of theta equal to 4. Anything is happening? What is coordinate of theta? 4. And dimension of F power 4 is 4 like R. Okay, dimension of F power 4 will be equal to 4. Whether both the dimensions are equal? Yes, one condition is over. What is the next one you have to check? Independent or not. So right, let alpha 1 u1 plus alpha 2 u2 plus alpha 3 u3 plus alpha 4 u4 equal to 0. Shall I skip this step, ma'am? Already we discussed so many independent constants. Shall I skip? Or you have to make? Shall I skip? Everyone knows now how to check if it is independent or not. We have to replace u1, u2, u3, multiply alpha, represent this as the equation, identify the matrix, check whether it is equal to 0 or not 0. Then you can discuss whether it is independent or not independent. Okay. So leave some space for that. Otherwise you will forget. Leave some space for that. Right? Beta is linearly independent. Beta is for working, leave a space. Don't write the answer continuously. Beta is linearly independent and forms a basis of R power 4. Forms a basis of R power 4. So F power 4. Forms a basis of F power 4. So one part is over. What is the next part you have to do? You have to identify that unique representation. The same way we are going to follow. But what will be the right hand side or the left hand side? Not one. Either a unique representation of alpha 1, alpha 2, alpha 3, alpha 4. Okay, that is unique representation of we already alpha use பண்ணதுனால என்ன பண்ணிட்டானா a1 a2 a3 a4 ல ஒரு எலிமெண்ட் ஆ அஸ்யூம் பண்ணோம். Okay, because linear independent use பண்ணும்போது what we did, we use the notations as alpha. Have you seen the question of norma? Yes, represent alpha 1, alpha 2, alpha 3, alpha 4 belonging to F4 as a linear representation of u1, u2, u3, u4. That is the step you are going to do now. Okay, put a subheading for your understanding. Represent A1, A2, A3, A4 belonging to F power 4 as a combination of U1, U2, U3, U4. As a combination of U1, U2, U3, U4. There is a similar to our linear span. Linear span la idha பண்ணிருக்கோம். ஒரு எலிமெண்ட் எடுத்து அத வந்து அந்த செட் எலிமெண்ட்ஸ் நம்மள எழுத முடியுமான்னு செக் பண்ணிடலாம். சேம் கான்செப்ட். So right? So what you are supposed to do? You have to represent A1, A2, A3, A4 as a linear combination of our U2s. So this should be equal to alpha 1 U1 plus alpha 2 U2 plus alpha 3 U3 plus alpha 4 U4. This is what you must try to find. You must write this as a linear combination of our U. In the right hand side, what are the unknown terms? Alpha. We are trying to find what will be our alpha values. Replace your U terms. Replace all the U terms. Alpha 1 into 1, 1, 1, 1 plus alpha 2 into 0, 1, 1, 1 plus alpha 3 into 0, 0, 1, 1 plus alpha 4 into 0, 0, 0, 1. These are the given elements, right? Yes. When I somehow solve பண்ணி you must try to find what is alpha 1, alpha 2, alpha 3, alpha 4 in terms of A1, because that is the thing we can find, because our left hand side is in terms of A1, A2, A3, A4, which is also an unknown values. Known values are the alpha and numerical and unknown. But in left hand side unknown இருக்கிறதுனால what should be your object now? Find all alpha in terms of A1. Tell me how can we proceed? How can we proceed? Rewrite this one. How will you rewrite this one? Alpha 1, comma, alpha 1, comma, alpha 1, comma, alpha 1. I am writing it up plus 0, alpha 2, alpha 2, alpha 2, alpha 2 plus 0, 0, alpha 3, alpha 2 plus 0, 0, 0, alpha 4. You understand what you are supposed to do? You take the coefficients on both the sides. So you must try to rewrite this right hand side in the form of the left hand side. Then one you can compare the corresponding groups. Okay, left hand side will be the vector representation. On the right hand side, what you have to do? Only one vector representation. Yes or no? So right hand side, what you have to do? Hey, left hand side la polynomial irukna, right hand side என்ன பண்ணுவ? Polynomial represent பண்ணா. அப்பதான் ரெண்டு பக்கமும் equating the terms on both sides. What is the first term in the left hand side? A1. What is the first term in the right hand side? Alpha 1. So therefore you got alpha 1 equal to A1. Now come back the second term. What is the second term in left hand side? A2. Right hand side? Alpha 1 plus alpha 2. Can you find alpha 2 or not? What is alpha 2? A2 minus A1. Because alpha 1 is A1. Bring it to the left hand side. Similarly, check for the third one. So third one is A3, which is equal to alpha 1 plus alpha 2 plus alpha 3. You know alpha 1, alpha 2. So what is alpha 3? A3 minus A1. Correct? Minus alpha 2. What is alpha 2? A2 minus B1. Simplify. A3 minus A2. Because minus A1 plus A1 will get cancelled off. Similarly, find alpha 4. So A4 will be equal to alpha 1 plus alpha 2 plus alpha 3 plus alpha 4. So you need to find alpha 4. So that is equal to A4 minus A1 is A1. So alpha 1 is A1 minus alpha 2 is A2 minus A1 minus alpha 3 is A3 minus A2. Find what is alpha 4? A4 minus A2. Whether all the terms are getting cancelled? Yes or no? We are able to find the alpha values or not? Yes. If the replace பண்ணி எழுதினா you will get A1, A2, A3, A4 as a linear combination of U groups. Okay, if they are integers means we can substitute and we can identify as a numerical value. Understood now how to solve? Yes. So right. Hence, the vector A1, A2, A3, A4 equal to the first line is alpha 1 U1 plus alpha 2 U2 plus alpha 3 U4 etc. Let us replace all alphas. That will be a final conclusion. Substitute all alphas and write. That is your final conclusion. We have written this first equation no ma. In this we have replaced the right hand side where alpha 1, alpha 2, alpha 3, alpha 4. That is the final conclusion. Now you have to conclude with that. When you started to do the procedure, you assumed an equation no. The vector A1, A2, A3, A4 is equal to alpha 1 U1 plus alpha 2 U2. Okay? In that one, you have to replace all your alpha values. What is alpha 1? A1. So A1 U1 plus what is alpha 2? A2 minus A1 into U2 plus what is alpha 3? A3 minus A2 into U3 plus what is alpha 4? A4 minus A3 into U4. You can give the final conclusion like this. But you have to replace here u1, u2, u3, u4 also. Okay, that should be the final format of our answer. Any doubt, ma'am? Any doubts? Okay, so everything is based on the same concept, ma'am. Okay, the way of representing one is going to be a different one. But எல்லாத்துமே எதை யூஸ் பண்ணுவோம்? Linear combination, linear span and then dependent or independent conditions. Okay, so discuss one more problem. Take down. Let's discuss one more problem. Find the coordinate. Find the coordinate of A. Here this is going to be a matrix form. Find the coordinate of A, which is a 2 by 2 matrix. 2, 3, 4 minus 7. 2, 3, 4 minus 7 in the real vector space. In the real vector space M. In the real vector space M, which is equal to M 2 by 2 of R. What is the meaning of this one? 2 by 2 matrix means 2 rows and 2 columns. And R represents real numbers. All the elements will be for real numbers. So continue. Relative to the basis. Relative to the basis. X is equal to 1, 1, 1, 1. Second element 1 minus 1, 1, 0. Third element 1 minus 1, 0, 0. Fourth element 1, 0, 0, 0. Since it is a matrix, all the elements will be in matrix form. 2 by 2. Tell me, how do you solve this? What is the question? Find the coordinate of A. Okay, relative to the basis in Rpla. So what is supposed to find? The same linear combination as we did before. So before, what was the statement? You are given a vector and you are asked to check, write that one in the representation of the basis. In your array now, instead of telling it as a write as a combination, they have given the both as the coordinate. Okay, there is another way of asking that same concept. So find the coordinate means what you are going to do? Again same thing. Left hand side you are going to assume A and you must try to write as a linear combination of U1, U2, U3 etc. And you define what is your alpha 1, alpha 2, alpha 3 etc. That will become as the coordinates. Okay, the same logic only, just they are using the word as the coordinate. Okay, so start the solution. Let A equal to other representation of coordinate not try to represent A in terms of the corresponding basis. So write as alpha 1 E1 plus alpha 2 E2 plus alpha 3 E3 plus alpha 4 E4. If you want, you can instead of E, you can write as A1, A2, A3, A4 since it is a matrix. That's our understanding. Okay. Now replace everything. What is the left hand side? 2, 3, 4 minus 7. Replace the elements in bases. Alpha 1 into 1, 1, 1, 1. Plus alpha 2 into second matrix 1 minus 1, 1, 0. Plus alpha 3 into 1 minus 1, 0, 0. Plus alpha 4 into 1, 0, 0, 0. What is a C box? What is happening there? Maybe something special is happening. Girls. Anything special is happening outside? Very present in the class. So you must try to solve and you must try to find your alpha. Previous case is was vector, so we did the vector addition. Now it is a matrix. atoms on both sides. Equating atoms on both sides. We get what is the direct answer? No? Alpha 1 will be equal to minus 7. So alpha 1 is equal to minus 7 from the fourth element. You can write in any order you choose. If you combine the third element, what will happen? Alpha 1 plus alpha 2 should be equal to, what is the third element here? 4. But what is alpha 1? Minus 7. So when you bring it to the right hand side, it will become plus 7. So what is alpha 2? 11. Now combine the first row, second element. What you will get? Alpha 1 minus alpha 2 minus alpha 3 equal to 3. First row, second element. So you know what is alpha 1, alpha 2. Find alpha 3. Alpha 3 will be equal to alpha 1 minus alpha 2 minus 3. Minus 2. Minus of plus? Minus 1. Now find alpha 4. First row, first element comparison. Find what is alpha 4? Minus 41. No? Others take it. Alpha 4. So alpha 4 will be equal to 2 minus alpha 1 minus alpha 2 minus alpha 3. Plus 41. Others? Why two different answers? Where the equations like along? So what is alpha 1? Minus 7. So 2 plus 7 minus alpha 2 is 11. Alpha 3 is plus 1. Alpha 4 is plus 9. Please be careful with the signs now. Minus and plus signs. So alpha 1 is 19. Previously the left hand side was an unknown A1, A2, A3, A4. So we got the answer like this. Since here the left hand side is a numerical value, we are getting all the answers to be numerical. So what is the coordinate of A? Alpha 1, alpha 2, alpha 3, alpha 4. What are the values? What are this? Minus 7, 11, minus 21, 9. This is alpha 4 or what? That is alpha 1. So right, final conclusion. Next, the coordinate of A is, hence the coordinate of A is, write a vector of alpha 1. So it will be minus 7, 11, minus 21, 19. This is the coordinate of A. So even if they give the word as coordinate, sorry, not coordinate, ordinate, right? Coordinate or coordinate? Ordinate meaning. Coordinate. So even if they give that name, you should know this is the same procedure. It is not nothing new. Okay, ma'am? Any doubt? So just one more concept, ma'am, with that this unit will be over. The same basis and dimension we are going to discuss for a subspace. Okay, this is for a vector space that we are going to discuss for a subspace. With that our unit 3 will be over. Okay, we will continue that in the